unprecedented.
লাইভ কি করে যেতে হয় হচ্ছে না কেন? হ্যাঁ, গো লাইভটা কি করে করেছি? শোন, গো লাইভ কি করে যায় এখান থেকে? ওই কিরে, এই শোন, বলছি বলছি গো লাইভটা কি করে করতে হয় সেটা এখানে আসছে না অপশনটা, কিভাবে করতে হয় রে? এখানে
এটা লাইভ হয়ে গেছে
কিন্তু চলছে না। এই হ্যালো হ্যালো, good afternoon my dear students. I hope you and your family are well in this unprecedented time. Today we will discuss about the basic things of about network theory. Before going to discuss about the basic elements of network circuit, let me tell you the syllabus of this course. Please see the syllabus of this course, Network Theory. You see that there are 4 sub-modules. First module is related to series and parallel circuits. Second module discuss about different theorems including Kirchhoff current law and voltage law. Third module refers the graph theory and also coupled circuit. And fourth module includes Laplace transform and two-port networks. In this course, we will cover these 4 modules. Everyone, please see the topics associated with these 4 modules. Okay. Next, I will share this syllabus with you, and you see the reference book to study this course, Network Theory. We will see or we will read this referred books. I have given here 4 reference books, but there are so many books for circuit theory available in market. But these 4 books are standard books, and whatever I will discuss or cover for this course, you will get from these 4 books. The first one is D. Roy Choudhury Network System. Second one is Abhijit Chakraborty Circuit Theory Analysis and Synthesis, and third one B.L. Thereja and A.K. Thereja for electrical technology, and last one Valkenburg, Amy Van network analysis. So apart these 4 books, you can see other books as you wish, or to understand this course in details, any topic, about any topic, you can see other books. But these 4 books are standard books. I will follow. Okay. I hope everyone knows means everyone has a good concept about circuit theory, because you just completed your first year course, first year second semester course, basic electrical and electronics engineering. So in that course, I think you have covered lot of things, but briefly. Now we will discuss in details about those things and also many new topics. Okay, you just see the syllabus, you can realize that many of the topics, subtopics you have already studied, but you actually studied briefly, not in details. Now you will study these topics in details. And another thing, as an electronics and communication engineer, you need to know the details about this subject, because this is an important subject, and this subject, many questions comes from this subject for most of the competitive exam. If you consider GATE exam, others engineering, government sector exam, even many private companies who actually working based on the circuit level actually concept or circuit design. So everyone need to know this subject in details. Okay, so thank you. Now we will discuss about the basic things of this course. So let me get start about the fundamental elements of circuit theory. So now Can anyone tell me what are the fundamental elements of circuit theory? And one thing you tell me, what is circuit? What is circuit? Tell me. To discuss many things associated with network theory or circuit theory, so first you tell me what is circuit? Anyone? What is circuit? What is circuit? Close connect. Arkadev Ghosh wrote that close connection of electrical components. Good. Arijit Acharya, network with at least one close path. Thank you, both of you. And Saib Raj, path for transmitting electric current. যেটা দিয়ে কারেন্ট পাস করে স্নেহা অধিকারী ওকে থ্যাংক ইউ এভরিওয়ান ইওর আনসার ইজ correct but the exact answer definition or electrical network definition you can write a circuit is a circuit is a close path close conducting path through which an electric current either flows or is intended to flow. Okay, so the answer of everyone is correct, but the exact definition or answer of this question is that a circuit is a closed conducting path through which an electric current either flows or is intended to flow. Mean your circuit you have designed, but you do not provide the supply voltage. After applying the supply voltage, you will get current from this circuit. Okay, now you tell me what are the parameters, fundamental parameters of a circuit. What are the fundamental parameters of a circuit? What are the fundamental parameters of a circuit? Can anyone tell me what are the fundamental elements or parameters of a circuit? Fundamental parameters of a circuit are its constituting components. What are these components? Saheli, your answer is correct. Resistor, capacitor, inductor and some basic element. Okay, Arijit Acharya, only resistance, current, voltage, or Pradeep Ghosh. Okay, the correct answer will be resistance, capacitance or inductance, or resistor, capacitor and inductor and some connecting wire. But fundamental are resistor, capacitor and inductors. Meters are resistor, capacitor and inductor. Okay, the fundamental parameters of a circuit are resistor, capacitor and inductor. Now we will discuss about these three fundamental elements or components. Okay, so I hope everyone has a good concept about this element, resistor, capacitor and inductor. But when we actually solve problems, we generally consider resistance value, capacitance value and inductance value. Now, anyone tell me what is resistance? Resistance or what is capacitance or what is inductance? Everyone knows. These are the properties of an element or substance. Okay, resistance is a property of an element, that is resistor, capacitance or a capacitor and inductance or inductor. These properties have some significance. You know, for if you consider resistor, then you know that there is a property that actually opposes the flow of current through this element. This element means resistor. Resistor has a property that opposes the flow of current through it. This property or that property is known as resistance. Resistance is a property, it a current ke oppose kore, right? Then you are correct. Okay. So similarly, capacitance is a property of capacitor that can store charge. Similarly, for inductor, that can store charge or discharge when you actually open the supply voltage. Now we will discuss other subclasses of the circuit element. What is linear element and non-linear element? What is linear element and non-linear element? Linear element what is non-linear element. Okay, what is linear element and what is non-linear? Linear element of a Ohm's law, Shanga Chakraborty has written that answer. And linear element which has a linear relationship between current and voltage, good, Sahib Raj. Okay, so both of you are correct. I mean your answer is correct. What is linear element and what is non-linear element? So everyone knows that linear element, this name implies that its input and output, there is a linear relation say between its input and output. Okay, and non-linear element is an element, an element is said to be non-linear element if its input and output has a non-linear relationship. I mean either current or voltage or current, whatever you can consider. So now you give me an example of linear element and non-linear element. Give an example of linear element and also and non-linear element. an element is said to be linear if its input and output relation say satisfies linear. An element is said to be linear if its input and output relationship satisfy linearity property. Linearity property. Okay, and then element is said to be non-linear element if its input and output relationship does not satisfy the input and output relationship does not satisfy the linearity property. Okay. Now, give an example of a linear element. And capacitor inductors are linear element. Arijit Acharya, linear resistor, non-linear diode. Your answer is correct. Orkodeep, transistor are non-linear. Yes, correct. Divyajyoti, capacitor inductors are linear element. Good. And Soily, PN diode is an example of non-linear element. Yes. Nivedita Bhagat, non-linear are elements are diode. Transistor, vacuum tubes are not. Yes, Divyajyoti. So all answer are correct. Whatever you have given. Linear elements examples are resistor, capacitor, inductor. You know, because their current voltage relationship is linear, and non-linear diode, transistor, etc. because their current voltage relationship is non-linear. Sogle relation, you know, satisfied. Okay, thank you everyone. Now you tell me what is when an inductor act as an open circuit element. When an inductor act as an open circuit element and when a capacitor act as a short circuit element. Okay, the next question is when an inductor acts as a short circuited element. Write the condition actually. And also you tell me when a capacitor behaves as an open circuited element. Okay, the next question is when an inductor acts as a short circuited element and when a capacitor behaves or acts as an open circuited element. You know, resistor is a power dissipating element and capacitor and inductor are power storing element. Okay, power storing element, capacitor and inductor. On the other hand, resistor is a power dissipating element. Okay, I hope everyone knows these things. Now you tell me when an inductor act as a short circuit. The answer, I got some answer. Orkodeep Ghosh has written that pure inductor in DC, capacitor in DC. Soheli has written R equal to 0 for a capacitor. It's when a zero current is passed through it for inductor. Nivedita. Zero current. So now anyone can tell me what is the expression of voltage drop across an inductor? Expression of voltage drop across an inductor. Write the expression. Write the expression of voltage drop across an inductor. Write the expression of voltage drop across an inductor. If the current flows through the inductor is I of T and the inductance value is L, and the inductance value is L, L di dt, right? Orkodeep, L di dt. Now you tell me the condition at which this inductor acts as a short circuit element. Short circuit element means what? There is no resistance, R equal to 0, and that time what will be the current? Current will be infinite, okay, and voltage drop will be 0, okay. So V equal to L di dt. So V will be 0 when at t equal to infinite. Please try to understand this answer. When an inductor acts as a short circuit element, the voltage drop expression, you know that VL voltage drop across an inductor equal to L di by dt, and we know that at short circuit condition, or situation, VL will be equal to 0. That means T tends to infinite. Sorry, small t is the time. T tends to infinite. Understand this point? We know that the voltage drop across an inductor is equal to L di dt, where L is the inductance, I mean self inductance of the inductor, and I is the current flow through this inductor, through the given inductor. Now my question is, when an inductor acts as a short circuit element? Short circuit means what? If you consider 2 points, short circuit means you have connected a metallic wire, when direct connection is there between the 2 points. Suppose A, B, short circuit means there is a straight line. That means there is no voltage drop, and at this situation, you know the resistance should be 0 and current should be infinite. So now if we put this condition that at short circuit condition voltage drop across any element is 0, so for this case VL will be 0. That means when VL will be 0, if L and I present, if t tends to infinity, time tends to infinity, means theoretically. So when t tends to infinite, then an inductor acts as an short circuit element. The right answer is an inductor acts as a short circuited element at time t tends to infinite. Mean time is equal to infinite theoretically. Time tends to infinite. This is the correct answer. Now, everyone understand this point? That why an inductor act as a short circuit element at t equal to infinite? Because at that time the voltage drop across it equals 0. Okay. Now tell me the answer of the next question. When a capacitor behaves as an open circuit element, when a capacitor behaves as an open circuit element, actually Divyajyoti, you see the expression of voltage drop across an inductor, and everyone knows this expression is the product of inductance value and the rate of change of current. At short circuit condition, we know that the voltage drop across the short circuit path will be equal to 0. Now, if we put the condition voltage drop at short circuit condition is 0 in the equation, expression of voltage drop across inductor, then you will get L di dt equal to 0. But when this will be equal to 0, there are L is a fixed value for an inductor, and I changing with time, this is also supply provided particular value. But t, with t change, t means when t tends to infinity, then this actually value di dt value will be 0. L into 0 will be equal to 0. That's why at times t tends to infinity or t equal to infinity, inductor act as a short circuit element. I hope everyone understand this point. Now you tell me, when a capacitor behaves as an open circuit element, similarly you can write that voltage drop across a capacitor Vc equal to 1 by C integration of it dt. You know, V equal to Q equal to Cv. So V equal to Q by C, and Q is nothing but the integration of current. So V equal to 1 by C right, dq dt, V equal to Q by C, right. So Arkadev, your answer is correct. Now you tell me, from this expression, the condition when this capacitor acts as open circuit. Open circuit means there is no current. Current should be equal to 0. Resistance should be equal to infinite. And at that moment, voltage will be no Divyajyoti. Your voltage will be infinite. No voltage of why? Open. Current is 0. Current is 0, but voltage is infinite. Okay, so at which condition current will be 0? Current will be 0 when t tends to, tell me anyone, the Arkadev Ghosh, your expression is correct. I equal to V equal to Q by C. Now you tell me the correct answer from this expression. At t equal to 0, how? At t equal to 0, then what you will get? The division will be infinite, dq dt, dq by dq by 0, dq by 0 at t, right, t equal to 0, t equal to 0. If you put 0, then I will be 0. If you put infinite, then I will be, actually t, if you put t equal to infinite, then you will get 0. Otherwise you will get infinite value if you put 0. So correct answer is t tends to infinite. Orkodev, your answer is correct. SK Nasir, 1 by infinite. Yes, Nasir, your answer is also correct. Right. So thank you for your answer. The right answer is at t tends to infinite, a capacitor behaves as an open circuited element at time small t tends to infinite. Okay. Now if I ask you when an inductor act as an open circuit element and a capacitor act as a short circuit element, then your answer will be vice versa. Okay, an inductor act as a short circuit element for t tends to infinite, and inductor act as an open circuit element at t tends to 0. And on the other hand, a capacitor acts as an open circuit element at t tends to infinite and short circuit element at t tends to 0. That vice versa of inductor. Okay. Okay. Thank you. Now you tell me what is bilateral element and what is unilateral element. Bilateral element and unilateral element. What is bilateral element and what is unilateral element, and give example of these two elements. I will Pritam Ghosh, I will take the attendance sheet from CR. CR will put name of all student, I mean those students who have attend this course, online course, and finally I will collect that list from CR. Okay, Pritam, don't worry, you just give your name to your CR. CR will send me the list of all students who have attend this course. Okay. When current in bilateral, the conduction is in both, right? SK Nasir. Soily, when current is able to pass in both directions, then it is called bilateral. Good. Unilateral element Orkodeep allows only one direction flow. X diode bilateral. Example, diode is a bilateral element. Diode is a bilateral element. Orkodeep, check your answer. In unilateral, the conduction in single direction. Bilateral conduction of current in both direction. Okay, unilateral current in not. Okay, now give an example of answer. Whatever given, all answer are correct, but Orkodev, you just check the example of bilateral element. You have written that example of bilateral element is diode bilateral, both example register one direct only one. Okay, right, Orkodev, you right. So example of bilateral element is The bilateral element means it allows flow of current in both direction. Examples are resistor, capacitors, inductors, etc. On the other hand, unilateral element, it allows flow of current only in a single direction. Examples are diodes, transistors, okay, etc. Okay, good. Now you tell me what is passive element and what is active element. Okay, next question is what is passive element and what is active circuit element, and give example of these two types of element. What is passive element and what is active element, and give example of these two types of elements. Two types of elements. Passive element, or Kodip, do not provide any gain. Example resistor. Okay. Or Kodip, your answer is correct. So passive element means this element does not generate signal or does not amplify any signal. So example of passive element is resistor, capacitor, inductor. This type of element does not amplify any signal. It has no capability to amplify signal. Example is resistor or capacitor, inductor, whatever. On the other hand, active element, this type of element can amplify the signal or can generate the signal. Example is transistor. Okay. Example, passive element can only receive energy. Yes, dissipate energy. Okay. Okay. Now you tell me what is independent source and what is dependent source. Independent source and dependent source. Before going to discuss about independent source and dependent source, anyone tell me how do you convert a current source into a voltage source? A current source into a voltage source. How do you convert a current source into a voltage source? Before going to discuss about independent and dependent source, you tell me anyone how do you convert a current source into a voltage source? How do you convert a current source into a voltage source? Anyone can tell me? How do you convert a current source into a voltage source? How do you convert a current source into a voltage source? Here we have considered independent voltage source. That means its voltage does not change by changing the value of other parameters present in the same circuit. Independent voltage source, independent current source means what? You know that the voltage or current of this source does not change by changing the value of other parameters in the same circuit, maybe passive elements or other elements, connecting wires, etc. How do you convert this voltage current source into a voltage source? Can anyone tell me the answer of this question? You know Ohm's law. Ohm's law tells us that current and voltage is directly proportional. V proportional to I. So V equal to, you know that, IR, where R is the proportionality constant, is nothing but the resistance. Multiplying the resistance with the current source, Ayan Kumar Pal, multiply, so you will get voltage IR. Good, by dividing with resistance. No, Cyan, you check your answer. Shomujit Kundu, V equal to IR, multiplying. Okay, thank you, Cyan, your answer is correct. By multiplying you will get the voltage. And how do you arrange this voltage and resistance for the final circuit? For the final circuit, I mean for the final current source. Tell me, anyone tell me, what is the internal resistance of an ideal voltage source? What is the internal resistance of an ideal voltage source? And also you tell me what is the internal resistance of an ideal current source. Then you can generate resistance, zero resistance for an ideal voltage source. Good, Nasir, your answer is correct. Shomujit Kundu, your answer is correct. Dibbojyoti Banerjee, okay, Ayan Kumar Pal, Right, answer is correct. And infinity for current source. So what will be the final circuit design for the ideal current source? Sorry, for the independent current source. The actually my question is, how do you convert a current source into a voltage source? So for voltage source, for current source, you know that its internal resistance is infinite, and this source is connected in parallel with an resistance. Okay. So for voltage source, you will get voltage V equal to IR by multiplying the current and resistance, and you will arrange the circuit that voltage source and resistance must be connected in series. Then you will get the ultimate voltage source from the given current source. Okay, thank you everyone. Your answer is correct. Okay, so these are the fundamental concept of circuit theory. You know that circuit is nothing but a closed path that actually formed by using a different circuit element such as resistor, capacitor, inductor, and it helps to flow current through it. Okay, if there is a voltage source or current source present in the circuit. Okay, after that different types of elements. What is linear element, non-linear element, passive element, active element, lateral, bilateral, and also energy storing element, energy dissipating element, they are example. And the fundamental things, that capacitor, inductor, resistor, and their different properties when they act as a short circuit element, open circuit element, etc. This concept will be implemented to solve different circuit theory problems, whatever we will cover in next lecture or subsequent lectures in future. Okay, so these are the fundamental concept. If anyone have any doubt, you can send me mail to my mail id, or you can call over phone. Okay, so let me stop today's lecture here. We will discuss in the next lecture about the Kirchhoff voltage law, and we will solve some problems associated with circuit theory using this formula. And another thing we will cover in next lecture about independent source, dependent source, and their properties. Okay, and their symbolic representation, etc. Thank you everyone.